because I have this. 2 more examples I got to cover before class, and then also we got to go over your homework. So, and in this one, again, guys, if you're struggling with this or trying to make conceptual sense, the best thing to understand when you're given zeros, especially if you're giving zeros in set notation, is just remember every 0 can be set just like how we solved them over there. X equals 0, x equals square root of 6, x equals negative square root of 6, and x equals 3. Then, to go from your zeros to their factors, basically if we're like reversing the zero product property, we just set them equal to 0. So this, you could say like x minus 0 equals 0 if you want to. But really, do we really need to write x minus 0? No, but it's a placeholder, and we'll just keep it for there right now. For here, the best thing to do is to subtract square root of 6, because if you square both sides, well, the problem is if you try to go backwards to this, you have to do plus or minus. And this is only the positive. So the best thing to do is to subtract the square root of 6 to give you there. Here, you're going to want to add the square root of 6 to both sides. And here, we'll subtract a 3. So now, these are each of the factors set equal to 0 to find our zeros, which again, all you have to do is apply inverse operations, and you get this selective zeros, right? So we can write these now as a product of factors. I'm just going to write x times x minus square root of 6 times x plus the square root of 6 times x minus 3. Yeah, I haven't got to that point. Then, after we write the product of factors, we want to go back and get to our multiplicity. And notice that we only have one 0 that has a multiplicity other than 1, and that's the x. So we're going to raise that to x cubed. OK? Now, I told you guys, radicals actually makes your life easier. It actually does. Because when you got to multiply this out, all right, we don't want to multiply some irrational times rational. I mean, we can, but it's just going to be a little bit more difficult, or just more work to do. Let's look at these two. What do you guys notice about those two? Special type of proctoring. What cancels? Well, the radicals, when you multiply them out, go away, right? Because square root of 6 times square root of 6 is 6, or negative 6, right? And then also the middle terms add to 0. Sometimes people call them canceling out and so forth. You guys can also look at your warm-up. Look at the factored form. The factored form, if you like unfactor that, you get x squared minus 7. So once you guys agree that this is just difference of two squares, we can easily just rewrite this as x squared minus 6 in the non-factored form, right? And then we have this times x minus 3. So now, all we really need to do is multiply these two binomials, which is not too bad. Let's give me x cubed minus 3x minus 6. I'm sorry, 3x cubed squared minus 6x plus 18. Then I distribute the x cubed, and I will combine. No, I don't need to combine. So then I'll just multiply by the x cubed. X is 6 minus 3x to the 5th minus 6x to the 4th plus 18x cubed. This was a lot less work than that, right? Yes? Yeah. So radicals are not all that bad. OK? They're not all that bad. So you actually should like when you see the radical